Hello everybody and welcome back to this channel. I am Dalekemi, and if this is your first time of watching my video, please do subscribe and like this video, and don't forget to hit the notification button so as not to miss any of my upcoming videos. Alright, so now let us discuss formal charge. So formal charge of an atom in a molecule is like an hypothetical charge of that atom in the molecule after the Lewis structure is correctly drawn, and it has a formula. The formal charge of that atom will be equal to the number of its valence electrons that it has minus the number of the non-bonding valence electron, because sometimes it's not all the total valence electron that an atom can use every time to bond. So the ones that it doesn't use to bond, okay, the number of them is the number of these non-bonding valence electron that's here, the minus half of the bonding electrons, that is the total number of electrons shared in bonds. Now let's look at some Lewis structure of some molecules and let's calculate the respective formal charge of each atom in there. Now remember, in the last video we discussed the formal charge of NO3 minus, and we discussed the Lewis structure of that, and we have this structure at the end. We have something like this, oxygen, and we have this, and we have another oxygen here. We have this, and we have the one here with 3 lone pairs of electron. Now say for instance we want to calculate the formal charge of this oxygen. We can use this formula to do that. And normally for oxygen, the valence electron it has will be 6 minus. Now if you check, out of that 6 valence electron that it has, how many does it use to bond and how many doesn't it use to bond? So it doesn't use 1, 2, 3, 4 electrons to bond, so that will be the number of non-bonding electrons. Okay, and this, the bonding electron or the shared electrons, half of it. So it is bonded to nitrogen with 4 electrons. So if you find the half of 4 is 4/2. So the total number of the formal charge now will be 6 minus 4 minus 2. That's going to be 0. So it doesn't have any charge. That's what we need. It doesn't have any formal charge. Now let's calculate for this second oxygen here. So the total valence electron of oxygen will be 6 minus the number of non-bonding electrons. So the number of non-bonding electron is a total of 6. Okay, it has 1, 2, 3, 4, 5, 6. That's the non-bonding, and minus half of the bonding electrons. So the number of bonding electrons it has is just 2. So when you find the formal charge, it will be 6 minus 1, and that will be 6 minus 7, which is minus 1. So in this structure now, they will put something like minus here now, so which is minus 1 for oxygen, because having a formal charge of minus 1. So the minus that you see here is the formal charge of that oxygen, and equally this one too we have a formal charge of minus 1. Okay, because if you calculate it, it will still be 6, the total valence electron, minus non-bonding electron, which is 6, minus half of the bonding electron. So that is just it. Now for nitrogen, let us calculate that. For nitrogen, the nitrogen has 5 valence electron minus the non-bonding electron here is just 0. It has no non-bonding electron. All its electron here in this structure are bonded. Okay, so it has 0 and minus half of the bonding electrons. Now the total number of bonding electron for this nitrogen is 1, 2, 3, 4, 5, 6, 7, 8. So that will be 8/2. Okay, so we have 5 minus 4, which is equal to plus 1. So in this nitrogen now, in that structure, you see that they will put plus for this nitrogen. So the correct Lewis structure of this NO3 minus will now be oxygen, okay, with this nitrogen, okay, oxygen, then the other oxygen as well. So they now put something like this bracket, and they now put, now if you now add all the charges together, so we have minus 2 minus, and we have plus 1, so that would be equal to minus 1. So that's how it is NO3 minus. So you have a minus 1 here on top of that bracket. Okay, so that's how they calculate the charge of that radical. Now let's look for the other ones too that we have done. For instance, the one of CO2, CO3 minus. So for CO3 minus, this is the Lewis structure. If you draw it correctly, the last time you remember that this is what we got, and we have this for CO3 minus. CO3 2 minus. So for this carbon that is here, let us calculate its formal charge. Let's start from the carbon. For the carbon, normally carbon should have 4 valence electron minus the number of non-bonding electron. It has no non-bonding electron. Non-bonding electrons are like these electrons now that are not participating in bonding, but for this carbon it has no non-bonding electrons. So that will be 0, the minus half of the bonding electron. So that will be the total number of bonding electrons it has is now 1 2 3 4 5 6 7 8 over 2. So that will be 4 minus 4, which is 0. So it has no charge. You don't put anything here. Now for this oxygen, if you calculate for that, it will be 6, the valence electron, minus the number of non-bonding electron, which is 6 as well. 1 2 3 times 2, that's 6, minus half of the bonding electron. So it's using 2 electrons to bond. So that will be 6 minus 7. 6 minus 1 minus 6 minus 1, that's minus 7. So the total will be minus 1. So normally you would T minus 1 for this oxygen, and for this oxygen equally you would T minus 1, because it will be 6 minus the number of non-bonding electrons, that's 6, minus half of the bonding electron, which is just 2. So that will be 6 minus 6 minus 1, 6 minus 7, which is minus 1. So it also have minus. And for the other one here, if you calculate, that will be 6 minus that, because normally the valence of oxygen will be 6 minus the number of non-bonding electron is 1 2. So that will be 4. Okay, minus the number of bonding over 2. So that will be 4 over 2. 6 minus 4 minus 2. That will be 6 minus 6, and that will be 0. So this one will not have charge as well. So the overall charge of this CO3 molecule will be, of this CO3 2 minus radical will be minus 2. And that's why when they want to draw the structure, they will just have something like this, and they will put 2 minus. So that's how to find the formal charge of molecules. So let's try one more example before we end the video. So let's try for the last one. Let's use H peroxide. So hydrogen peroxide, let's use that. So it will have H, oxygen, H. So let's start from this hydrogen. So hydrogen normally have 1 valence electron, then minus the number of non-bonding electron is 0. It has no non-bonding electron, and half of the bonding electron, half of 2. That will be 1 minus 1, which is 0. So it has no formal charge. The same thing for this hydrogen to no formal charge. Now for these 2 oxygen, let's try and do that. So that will be 6 minus. So the number of non-bonding electron it has is 6. Okay, and right, it has 6. Oh no, it doesn't have 6. It has 2. It has 4. This is non-bonding, and this one too is non-bonding. These other 2 are bonding. So that will be number of non-bonding electron will be 4, like that. And minus half of the bonding, so it has 4 for bonding. Okay, so that will be 4 over 2. So that will be 6 minus 4 minus 2, and that will be 6 minus 6, which is equal to 0. So it has no formal charge, just as the 2 hydrogen. So for oxygen 2 here, that's A. So it will be 6 minus, so it has 4 non-bonding electrons and 4 bonding electrons. That will be 4 minus 2 over 2. So that will be 6 minus 4 minus 2. That will be 6 minus 6, and that will be equal to 0. So that's all for this video. So it means that total they don't have any charge. So there's nothing like this bracket there again. You don't need to put any bracket, and you don't need to add any charge. And even if you want to do that to be 0, which is totally ridiculous, so you don't need to put anything there again. So that's how to find formal charge of an atom in a molecule. Thanks for watching, and don't forget to like the video and subscribe.